Well, welcome back. And this is the second video about numeracy. And I've got as my text the Pia Westwood book, and we're now on page 150. And it's assisting students who struggle with maths. So let me just read some of the things from the dot points there. Providing individual help that is matched to the student's current level of understanding. Giving additional practice to achieve mastery of basic facts and procedures. Sequencing the curriculum material carefully and controlling the task difficulty. Providing extended time to complete assignments and to work on problems. Encouraging the use of concrete materials and reading the word problems aloud to the students. Permitting the use of a calculator and using cue cards to display the steps in carrying out this process and facilitating individual support. So I guess the question is, what should be taught? Well, as I said to you before in the last video, I really believe the importance of mental arithmetic, so that this has to be mastered from kindergarten level. And it is currently agreed that all students should be helped to engage with core mathematical curriculum. It is some people would say that a student who has difficulty in maths should be taken aside and doing small group work. But if that small group work is not engaging or interesting or relevant, then the children are not going to be motivated to learn. Now, we know that all lessons need some adjustments, but most researchers are agreeing that there has to be relevant mathematical elements and that problems should be integrated into other subjects, into real life situations. So I guess we're not learning maths just for the sake of learning maths. It has to be relevant and there has to be an integration into the other subject areas. Now, most of us know that to remediate a problem, we actually have to have a diagnostic approach. And the only way we can do a diagnostic approach is to find out what the children know and what gaps there is in their knowledge, and then precisely work out what that gap is and allow them to remediate that gap, and that will then give them a better attitude towards mathematics and a level of confidence. Children's errors give us a lot of knowledge about what they can and can't do. And so my own thinking is that we should be giving children a problem and asking them, what are you thinking? What is going on in your head at the moment? So we can find out what steps that they're taking and discover what the gap is, and then the skill that needs to be identified. So there are 3 levels of diagnostic work in mathematics to be conducted: the concrete, the semi-concrete, and the abstract. Now, the main goal of teaching mathematics to students is the development of problem-solving skills, and therefore assessment of the student's current ability in the domain is important. Now, when we are looking at problem solving, we need to be detecting what is called for the problem, identifying the relevant information, selecting the correct procedure, estimating an approximate answer, computing the solution, and checking the answer. And for our own thinking, as teachers, we should be saying to ourselves, why did this student get it wrong? Can he or she carry out the process if allowed to count on their fingers, use a number line or a calculator? And ask the student to work through an example step by step. Can he or she explain the mathematical process, and at what point does the student misunderstand? So let's think about learning from concrete materials, real and structured materials. Let's have a look at what things are available to us in classrooms. Well, if you were to go into a kindergarten class, you might see these little bears, and they'll do counting and they'll count the bears, and they enjoy it. They love counting little bears because children in kindergarten love teddy bears, and so that fun is quite motivating for them. But also you will find that in concrete materials are showing that's one, and put them together, we're going to get 2, and put the next one together, we're going to get 3, and 4. In all that we do with concrete materials, we've got to show relevance, and we've got to show that number is a concrete thing. The first thing we can always show children is our hands. You know, these are 5 fingers. Here, you count your fingers, altogether you've got 10. I know that in some of these skills that we teach children, we can actually use the fingers to do mathematical computations on them. Another thing we do is to use dice and get the children to tell us the numbers and roll the dice. Another thing we have in classrooms is these little shapes, and shapes for the sake of shapes is fine, but there has to be some relevance to the real world. Another counting device that we use in kindergarten are paddle pop sticks. This is what I love. Paddle pop sticks are very easy, they're very cheap, and you can easily get out 10 paddle pop sticks. And as I said to you before, I think it's really important that children understand 10. 10, whether you do 5 and 5, you can actually manipulate these paddle pop sticks, and the children can show you, well, there's 5 and there's 5, and that makes 10. What about 4 and 6, and then 3 and 7? And that number, the concreteness, we're then trying to teach them how important it is to know the 3-ness of 3 and the 7-ness of 7, that it is concrete, but there are patterns, and that's why I love being able to talk about how God made these perfect patterns. There's perfect order in maths. The other thing that we can use in is any kind of counters that you've got. It's great, and I just picked these up from the kindergarten room. The number line. We all love the number line. I love the number line because we can count on the numbers, and the children love doing that. But I think we have to start remembering that we just don't always start at 1. That we can start at 3. At 3, count on, and then stop at 9. So that children are seeing there is a sequence, and that it doesn't always start at 1. Some numbers start at 5, and we can count on, or let's count at 2. Let's go backwards. 2, go backwards, 1, goes to 1. And look at 5. Let's go backwards, 3. 1, 2, 3, and we get 2. That is really important, a number line for adding and subtracting, and doing lots of it, and getting confident with it. And once we've done this number line, we can then move on to the larger number line, and that goes up to 20. Again, decimals, knowing that we live in a society based on the decimal unit 10. Counting is probably one of the most fundamental skills that children need to have, and it can only be acquired in the beginning through concrete materials and direct instruction. Counting of actual objects will eventually be extended to encompass the counting on strategy for addition and the counting back strategy for subtraction in the absence of real objects. It's important that we directly teach these things to students. Students also need to know that 9 is a number, that 1 is a number, that 2 is a number. I love it in the kindergarten because they say on the first day God created light and dark. On the second day, God created the water and the sky. On the third day, you guessed it, God created the land and the sea. And on the 4th day, God created the sun and the moon. And on the 5th day, God created the animals and people. And on the 6th day, he created animals and people. And on the 7th day, he rested. Now, you might say, well, that's great, Tina, but I've got students who are adolescents. Well, my thinking is that, yes, some things may not be appropriate, and we've got to think about age-appropriate things to use. There are always things in a student's environment that are age-appropriate, that we can use to teach them these mathematical skills. The important thing is that students know how big a number is or how small it is. Do the students know that 20 is bigger than 2? Do they know that 200 is smaller than 2,000? Do they understand place value? We often find that students get very confused with place value because they don't understand the bigness or the smallness of numbers. So there's that awareness, that visualization. And so it's really important that students understand numbers and how to write them. Number facts, as I said to you before, the counting on numbers, times tables, adding tables, subtracting tables are really important to become automatic. And I think that when a student has that skill, they can do things in their head, that when they then have a real life problem, they don't have to then remember 12 plus 2, and then they lose sight of the main problem that has to be investigated because they can't do easy computations in their head. We give them a real advantage if they're able to do a lot of mental calculations automatically without having to think about it. Then when we start teaching computation skills, like vertically 12 plus 13 equals 25, do the children know that the vertical computation 13 plus 25 is the same as the horizontal one, that they're both the same. A horizontal, vertical is the same computation. And we can sometimes use our maths blocks to show these little blocks if the children don't actually get it. And that's why concrete materials are really important. When we're giving computations that involve adding 10 to a number, it's important then that we have a script. Teachers say 25 minus 9. How do we do that? Well, we add 10 and we give 10 back to the other side. And then we say 15 minus 9 equals 6. And 2 minus 1 is 1. When we do that sort of computation, we teachers have a script. But then if our parents don't have the same script, or if a remedial teacher doesn't have the same script, we can be giving children mixed messages. They're thinking, oh, well, one teacher's teaching me one way to do something and my mother's teaching me another way to do it, and my remedial teacher is teaching me another way. It's really important that this child learns one script and practices one script. If they don't understand that same script, we can give them a different script or a different process. But again, all his tutors have to be using the same script. And that's important in a school. When you're doing computations, and a computation is being done in maths, and a computation will have to be done in geography or in economics, has the teacher in those other subject areas the same way of doing the computation as the maths teacher? And that's a discussion that we should be having at staff room level, so that we're all giving the students the same information and we're not confusing them or throwing them. We do know that calculators are important in maths. And in the Australian curriculum, we know that we introduce calculators as early as year 3. But it's not to do the computation with the calculator, is to check the solution with the calculator at year 3. That's a different skill. By year 7, we think that students should be able to investigate problems and calculate them without digital technologies. So we don't want the children to use the calculator to do the thinking part or the initial computations. We want them to spend time with mental computations and then be able to check their answer. I think sometimes as a last resort, we use a calculator, but teachers should never abandon the teaching of paper and pencil from computation skills. And I think that in some of the computations in an assessment task, teachers give marks for students being able to work out different parts of a problem. And that's important because we do want our students to be able to think through and solve this problem. Now, I'm now reading from page 157, developing problem-solving skills and strategies, because as I said at the beginning, maths is problem-solving. The whole purpose of mathematics education is to acquire information, skills and strategies that enable an individual to solve problems that they may encounter during school time, work life, at home or during leisure. Children therefore need to be taught how and when to use computational skills and problem-solving strategies for authentic purposes. So it's generally accepted now that there are recognisable and teachable steps through which an individual needs to pass in solving mathematical problems. These steps can be summarised as interpretation of the problem to be solved, identification of the processes and steps needed, translation of the information into an appropriate algorithm, careful calculation and checking of the results. Now, it's also recognised that 5 steps, there are also significant metacognitive components. These components include self-monitoring and self-correcting while working through a problem. For example, the student must think, what needs to be worked out here? How will I do this? Can I picture this problem in my mind? Is this working out okay? How will I check if my solution is correct? I need to correct this error and then try again. When teaching a problem-solving strategy, the teacher needs to model and demonstrate the effective use of the strategy for solving the problem, think aloud as various aspects of the problem are analysed and possible procedures for solution identified, and reflect upon the effectiveness of the procedure and the validity of the result. Now, this author suggests that the students learn the mnemonic RAVE and CCC. Now, RAVE stands for read the problem carefully, attend to words that may suggest the process to use, share or together less than how many, visualize the problem and perhaps make a sketch, diagram or table and estimate the possible answer. The letters CCC suggest what to do next, choose the numbers to use, calculate the answer and check the answer against your estimate. Additional teaching points to consider when improving problem-solving abilities of students are these. pre-teach any difficult vocabulary associated with a specific word problem, provide clues such as directional arrows in which to proceed, link problems to real-life experiences, provide examples that are usual to establish and lengthen the application of a particular strategy, give children experience in setting their own problems for others to solve, stressing the value of self-checking and self-correction, and using appropriate computer-aided instruction. I think for teachers, it's really important to model the question and model it and show the children what you're thinking and give them this really important demonstration. Then the next step is to use what I would call guided instruction, so that you